So welcome to day 3 of workout 3.1, and today we're going to be looking at two workouts. We're going to look at workout B and F. Okay, so B is the second one on this sheet. We did workout A on day 1, so now we're looking at workout B and thinking about multiplying a single digit by a 2-digit number. If we look at these, we can see that all the 2-digit numbers are teens numbers. So we might want to practice solving these by partitioning and recombining. So if I'm thinking about if I had an array, do you remember doing this? That if I had an array that was 4 by 14, yeah, I can split my 14 into 10 and 4. Okay, so if this was full of dots, say 4 rows of 14, this bit here would have 40 in it, 10 lots of 4, 4 lots of 10. This bit here will have 4 lots of 4 in it, 16. So therefore, well, you can carry on from that yourself, can't you? Thinking about combining those to work out what 4 multiplied by 14 is. So have a go at doing them mentally with jottings rather than as a formal written method. Let's practice our mental strategies today as we do workout B, then come back and get some answers. So here's our answers to workout B. Just have a little check through, see how you got on, and do any corrections that you need to. Make sure that if you've made a mistake that you understand where it went wrong, and maybe do a jotting just to unpick it. Okay, and let's have a go at workout F. Colin's collected he's got cards with triangles and quadrilaterals on. Now I've got some here, you don't necessarily need them, you can do some jottings or you could just do some counting in your head. So there's quadrilaterals means 4 straight sides, doesn't it? So there's one quadrilateral, 4 straight sides, there's another one. So altogether there I've got 8 straight sides, haven't I? And another quadrilateral is another 4 straight sides, so 3 quadrilaterals, 3 4-sided shapes would give me a total of 12 sides. Yeah. And so on. So I could keep counting in 4s if I've got quadrilaterals. Every quadrilateral has got 4 sides, hasn't it? So if I'm thinking then about triangles, then obviously every triangle has got 3 sides. So if I've got one triangle, it's 3 sides. If I've got 2 triangles, then it's 2 lots of 3, 6. 3 triangles would be 3 lots of 3, 9, and so on. Let's find out what Colin's up to. He picks some cards, triangles and quadrilaterals, and there are 48 sides in total. How many of each type of shape might he have chosen? Oh goodness. So we know there's a total of 48 sides, and we know it's made up of quadrilaterals or triangles. What could the combination be? If you go and have a go, then come back and have a look if you want a hint. So if we want a hint, think about what we're doing here. Yeah, we could think about how am I going to make 48 out of 4s and 3s? So I could list some multiples of 4. And I could list some multiples of 3 maybe. And to see if I can find any combinations that will make 48. There's nothing there. There aren't enough. The biggest I've got there so far is 28, isn't it? All right, so I'm going to need to keep going. Think about if I had some more quadrilaterals. I could have, if I had 5 quadrilaterals, 5 4s are 20, 24, 28. Now we're up into numbers that might be a bit more useful. So then I'm going to look for a combination of some triangles and some quadrilaterals that would make 48 sides in total. When you've solved that challenge, there's an extra challenge here that says, well, what if the total number of sides was 60? So having found a solution here, how can you adjust that solution to give you 60 sides? Then when you've had a go at that, if there were octagons in the collection too, how does that change things? So if you were going to go back and do 48 sides using octagons, quadrilaterals and triangles, what would happen now? Off you go.